Hi, it's Gadget UK here again. Just a short video. You can see got a brand new SCART RGB cable here from Cool Novelties. These cables are really good. I've got them for various systems in the past and they tend to be fairly cheap and affordable. The issue with this one, as I'll show you, it switches my TV into composite mode rather than RGB, despite the fact it's been advertised as an RGB lead and all the wiring is in there to make it an RGB lead. So I've got it plugged in there, and if I switch it on, just watch, it's a CVBS. Did you see that at the top? That's composite. Yeah, CVBS. It's composite video blanking signal or something like that. I don't know what the S stands for. But that is composite. Yeah, so I'm not sure if you can see that it's a bit blurry and stuff. You've got the normal problems you have there with the composite signal. Yeah, so that's what it looks like in composite. I'm going to see if I can get this working as it should do. Right, so I think I've worked out what's going on. The black wire coming into here comes into the third pin from the top, which is, you know, here, pin 16. You can actually see 16 printed on the plastic there. Now, from memory, what you normally do is have a 180 ohm resistor down to where the orange wire is connected here. That isn't what's going on here. They've got a separate orange wire. So I started this video thinking this would be really super easy. It's as things have transpired, it's been a nightmare. I've had the scope onto this. I'll show you one or two of the signals on the lead in a minute. But I have spent a few hours, it's been a few hours yesterday, and a few hours today, trying to work out and make sense of what's going on. So I think the root of the problem is that there is no 5 volts coming out on the video connector. You get 12 volts. Can you see that? And if I press the select button, we now have RGB. But obviously, that's not right, it's rolling. So I need to do something further. So it's looking a bit of a mess, that. I'll tidy that up when we're done. The V-Sync connection here going to pin 16. As you can see, I've got a capacitor from its negative side to ground and the positive side in line with that V-Sync. So that's going to smooth out that what will be a pulse, an occasional pulse, to more of a robust voltage level, a DC level, because you need something like, and again, these voltages vary a little bit depending on where you look, but on a few of the tutorials and things to do with the SCART pin out for the ST that I've seen, it says that between, I think, 1 and 3 volts should put it in RGB mode. Less than that puts it in composite, and higher than that, seemingly, it puts it in composite. So if you were to feed the 12 volts to the orange wire here, it still ends up in composite. But with this cap here, we've now got it in RGB finally, but we've got a rolling picture. Now, the other thing I saw as well and did wonder about is the theory of sticking a diode in the anode on the V-Sync signal and the cathode coming to the point here. Obviously, I'll trim these things down later to not only drop the V-Sync signal by a little bit, but stop anything being backfed and interfering with the V-Sync signal. Because as far as I can see from the connectivity tests I did, the V-Sync signal that comes out on the video port from the back of the ST goes straight to the glue chip and various other things on the motherboard. So in theory, you risk damaging the glue chip, and also any interference there could affect things and could cause weird behaviour within the system. There's no buffering or isolation or anything. There's no transistor or diode or cap or anything between there. As far as I could see, I did a measurement continuity and I had a direct short from the V-Sync pin to the glue chip. So I think what we'll do, we'll try sticking a diode, anode on the V-Sync connection, cathode to where it's currently soldered there now. See if that's any better, see if it still is rolling. If it's rolling, we may need to add a cap or something, or a resistor back onto the composite signal there. Maybe that's something to do with it. Oh yes, sweet. If I switch that now, you can see it's RGB and it's not rolling. So I think the reason it was rolling is because without a diode there, that capacitor is going to charge and discharge as the V-Sync signal changes. Yeah, because there is no isolation between that V-Sync signal and the rest of the system, obviously it's going to affect timing of things. So you're actually shifting the V-Sync signal pulses there, the rise and fall of the logic level. Instead of it being a square edge, nice square transitions. It would probably be dropping a little bit, dipping as that cap discharges due to the drain on it and the capacitor charging, discharging, charging, discharging. So yeah, and now we've got the stripes down here. A few people have mentioned you can get these stripes like that, jail bars. Let me zoom you in. Yeah, zoom in a little bit closer there. Can you see that? We've got like green lines down the display. Sorry, it's wobbling a lot there. Anyway, so maybe we can do something with that. Let's just turn the volume down a bit because it's super loud. Let's stick a disc in and see what it looks like. We might be able to live with it that way, but we might be able to do something further to it to improve it. Yeah, we've got jail bars. Yeah, this could be the quality of the cable though, if I'm honest, because there's no separate shielding around the red, green and blue. And the other thing we may benefit from here is a resistor on the composite signal, because at the moment there isn't one on there, so let's just hit fire. So yeah, I tell you what, that is reminiscent of the Mega Drive. The jail bars there do remind me very much of how it looks on my Mega Drive, if I'm honest. Yeah, so that's far better. Yeah, so if you look at that now, that is far better. The detail is much more clear, it's much more crystal clear. But we do have that jail bar thing going on, which is more visible here. You might just be able to see some lines coming down, but again, that may get lost in compression of this video, I'm not sure. But overall, that is far, far, far better. Whoa, I've sorted it. It looks pretty much perfect. I don't know if you can see, but all of the blue jail bars have gone. What I did is just attenuated the composite signal further. Now, originally I had an 82 ohm resistor, let me just power cycle that. Had an 82 ohm resistor on the composite signal, and that's way too low. Now I tried it with that, it was awful. Just the same without a resistor. So it made next to no difference here as well. I can see all the lines that were down here have gone completely. There's maybe a slight remnant I can see in the odd place there, but it's hardly visible. So maybe I could reduce the signal further there, put a larger resistor. But anyway, I went to 330 ohm and I noticed a significant difference straight away. The same on the sprite. Let me zoom you in. I don't know if it was clear before, but there were little lines down the little sprite there. If I just start the game, see the blue here? I don't know whether it's going to capture very well, but the lines are not there. There were major lines down there before. There's the odd bit of ghosting in places, but that is so much clearer. So the final size of the resistor there was 1K. Now, I think I could probably go a little bit further. One thing I haven't done is scope it under load. So when I say under load, I mean when it's connected to the TV. You've got termination resistors at the TV side. So in order to see the voltage level accurately, you would need to be scoping it while it's connected up, or terminate it, stick some 75 ohm resistor or something there, I think. Anyway, we'll have a look at the cable now, and then I'll clean it all up, heat shrink off the various things that need heat shrinking. And I think we're done. I'll test it on my other ST, which is a totally different revision board, just to make sure it's definitely 100%. But I'm very pleased with the end result. So there's the work in progress. As I say, we'll tidy this up now, because we don't need crazy long wires, and we want heat shrink, and we want to clean up, melted the plastic here. We'll file that down, smooth it down, re-solder things, and it'll look really tidy and presentable. So we've got a 47 microfarad 10 volts cap here. Its negative side goes to ground somewhere. You'll have lots of grounds on these. You can see here, these little loops, the black loops that go like that. Those are the grounds that they hop from one place to another, to another, to another, over here to the audio ground, I think. So there are numerous places you could tap the ground for the negative side of that cap. The side with the stripe there, that's the negative side. And the positive side is going to pin 16 here. So from the inside, it's like the third one down on that top row there, where the black wire was originally going on this. So and I've got a diode, and I would recommend this diode should be there no matter what cable you're using, RGB, whoever manufactured it. If it's not got a diode there, in theory you're risking damaging the glue chip, in my mind. Post below if you think I'm wrong, but I'll show you why. We'll measure connectivity on the board in a second. I'll show you why I strongly believe you should have a diode on there if you've got the V-Sync signal being used for the switching pin. An R1K resistor in line with the composite signal, that comes into this top pin here. It's the furthest most pin up here on that top row, that one in the corner there. So yeah, that's it. As I say, maybe you could attenuate further, and you might find it varies a little bit depending on what TV. If you plug this into like an old TV, I've got no idea. Will it work? Will it not work? I honestly don't know. I would think it probably would. What I might do is connect it up to the Commodore 1084 to see what it looks like on that as a final thing within this video here. But right now, I'll take the lid off this and I'll just show you the connectivity issue. So we've got the cable plugged in there. We're on continuity test here, and if I pull the cable into view here, if we think about this, which way around is it now? It's the black wire we need to probe. So if I probe from there, that's where the black wire comes out. That's our V-Sync signal. And again, I'm just risking this just by touching touching that. This is the thing, because it's plugged in theory, my hand is connected straight to the glue chip. If I probe down here, first of all, see we've got a dead short on the meter at 000. I know that pin there, hang on, that pin there is the V-Sync pin. So it's quite fiddly to show you everything at once here. I've had to pull this apart further. So the pin over there, which is the V-Sync, that was our V-Sync signal over there. If we probe this pin here, this is the V-Sync on the glue. Again, we have a dead short. So yeah, if you're using the V-Sync pin on one of these SCART cables to, for the RGB switching, you should have a diode on there. Just by virtue of touching the SCART connector with your hand, you could introduce some ESD down that connection there, straight into the glue chip. And these glue chips do fail. I replaced a few of these back in the day. Was that the cause of the failure? I don't know. But actually, in the instances I replaced them, I would say I think one of them did have a problem with the V-Sync. So you never know, it could have been something like that. But if we scope the V-Sync signal coming in, it doesn't really matter whether it's on AC or DC here, but can you see we're getting pulses? It's not a flat straight supply rail. It is around 4.3-ish volts there. But this is why this cap is important here, because on this side here where you've got the cap, it levels it out. That cap charges up, and because the negative peaks, where it goes down to a lower level, a logic low, are so infrequent, that cap holds the charge for that period of time and it smooths out the supply. So all we're using the V-Sync for here and this is providing, just less than 5 volts to put the TV in RGB mode, and that works for me fine here. And as I say, I've seen that same technique used in other cables. It's probably technically not exactly the right way of doing it, because there is quite a tight threshold of logic levels that are associated with SCART standard there for switching a TV into RGB mode. As I mentioned earlier, I think it's something like between 1 and 3 volts or something. So if this is outputting 4.3-ish volts there, technically that's not right, but my TV is happy with that, and that's all I am bothered about. And there we go, all cleaned up. So we got 1K on the composite, diode on the V-Sync, a cap between the V-Sync on the positive side and its ground going to the audio ground, heat shrink over everything, all shrunk down there. So it could be quite tight trying to fit this all in the hood here, but let's give it a go. I always forget which way around this goes. I think it goes like that, doesn't it? Yeah, so this is where you need to manipulate these things and try and push them in line. Try and move that away from there, because can you see that cap, there's a little bit exposed just on the end there. It's quite hard. Got a bit of solder on there, look. Yeah, it's quite hard to get that just right, but I think that's it. I think if we close that, there we go. And if we tighten that back up again, we'll just give it one final try here. We'll perhaps try a different game. As you can see, that is looking sweet, so let's start the game. Sorry, I know we've got massive light glare there. Wow, that looks fantastic, absolutely fantastic. What I might do is just connect this up to the PC for you, and do a direct capture just so you can see how good it looks actually. But I'm very, very pleased with that. The annoying thing is, that cable, I bought it brand new from Cool Novelties. You know what, I've had to do all these mods to it. And it's the same with both my STs. So, yeah, if you've got an old TV, CRT or something, maybe you wouldn't have had an issue. You could have connected it up as was, and maybe it would have worked. But you know what? If anyone from Cool Novelties is watching, maybe consider doing some of these changes and test it against a number of different TVs and monitors and things yourself. Because at the end of the day, we just want everyone to have good stuff, don't we? I want everyone to have good cables. And of course, the other thing that could be improved with this Cool Novelties cable, as I mentioned, is it's not fully shielded. You know, so like the RGB, if you to separate each of those with their own shield, you'd get an even cleaner picture, and you could do the same with the sync as well. And that's typically what the good cable manufacturers will do, as well as paying attention to the impedance of the cable. You know, the type of cable you use will have a resistance associated with it, and that's key too. A lot of the really, really good cable manufacturers pay very close attention to that sort of thing, and the quality of the connectors as well. You can find out more about that sort of stuff on the Retro RGB channel. He's quite what's the word? You know, an expert, if you like. He knows all the experts, people like Voltar, people like that are very clued up on this stuff and put a lot of time and energy and dedication to making sure that we get the best video out of these things. But I'm very, very pleased with what I've been able to achieve with this. So I hope you found that interesting. I hope it was useful to somebody. Yeah, these Cool Novelties cables, they're cheap, and I'll be honest, some of the cables they do are really hard to find anywhere else, like an Atari Jaguar cable, for example. And I've got no problems with that Jaguar cable. It's crystal clear, it switches it over, all, you know, it does everything. But this ST cable, yeah, it could have been better. Well, no, it is better, I think, in my mind. Anyway, thanks for watching. I'll catch you in the next video.